Okay, good evening. Last class we had seen about the ACB, selection of ACBs, which we had seen in this panel, LV panel Form 2 design. We selected in last 3-4 classes. We discussed about the selection of ACB with respect to ABB. We did Emacs. We checked the catalog of Emacs, selected the frame sizes E1, E2, E3, E4, E6. And we initially discussed about the operation on-off operation using the handle as well as the motor. Then we discussed about the technical characteristics, rated current, ICU, braking capacity, withstand capacity, service capacity, and ICM making capacity, and some other voltage characteristics also, rated voltage, operational voltage, impulse resistant voltage, and insulation voltages. And after that we checked the available ampere range with respect to braking capacity. Like we selected for 1600 amps 3-pole ACB 50 kA since we went with E1N16 breaker. And next we checked about the trip unit. We have electronic trip unit here, LI, LSI, LSIG with the 3 variant, PR121, 122 and 123. PR121 it is purely static type, which will have dip switches to set the parameters. Overload setting can be set between 40% to 100% of the rated current of the breaker, and short circuit values can be set between 1 to 10 times of rated current with respect to a minimum time delay like 0.1, 0.2, 0.3 seconds. That is S version. With respect to I version, instantaneous short circuit. S means selective short circuit. We can adjust the time also. With respect to instantaneous, it is adjustable from 1 to 10 times, which will trip instantaneously when the current reaches the set value. And G represent the ground fault, which we can set between 0.1 to 1 times of rated current with respect to earth fault. So LI, LSI, LSIG, 3 variants are available. We can select any of the 3 as per the requirement by the customer. Apart from that, we selected so many accessories of the breaker, like shunt open release, shunt close release, and geared motor for automatic charging of springs, some locks, interlock between the breakers, type A, type B, type C, type D, 4 types we had seen, between 2 breakers and between 3 breakers, and some more accessories related to indications for breaker on and off, withdrawable, rack in, rack out, and test isolated position, and so many locks we had seen, trip unit indication purpose and all. So apart from that, what else we studied in ACB? So finally we went with this ordering page. We selected the exact part number of the breaker with respect to frame size, based upon amps and K rating, and with respect to the trip unit, static or numeric, with LI, LSI, LSIG variants, and the necessary appropriate accessories of the breaker. This is all we studied about ACB. Now we are going to select the MCCBs, which we are seeing here, Q1, Q2, here Q5, Q3, Q4, Q6 and Q7. We are going to select all the 7 MCCBs. I will just recollect you this load schedule which we are following. So for this is the load schedule which we are designing the panel for. So here we can see 1600 amps ACB 3-pole 50 kA incomer. We selected this one in last session. Today we are going to see about how to select the MCCBs. 630 amps 3-pole MCCB 36 kA, 400 amps MCCB 36 kA, 250, 200, 300, 200 and 32. Again we are going related to ABB brand T-Max catalog. The ACB one is E-Max, this one is T-Max. So we are just going to go through the important section of the catalogs, and finally we are going to select for all these ratings how we are going to select the breaker with respect to amps and braking capacity, again also with respect to the trip unit, available trip units, what are all needed for this breaker. So for this I am going to T-Max catalog. Here I have this Tmax. Now ACBs are available from 800 amps to 1600 amps. This MCCB it is available from 160 to 1600. That is ACBs from 800 to 6300. We had E1, E2, E3, E4 and E6. This is related to ACB, that is ABB brand. For other brands also, the ratings, everything will be same, only the model, brand names and model names will be different. Like in Schneider, they call it NS breaker, NW breaker, NT breaker. Here they call Emax and Tmax. MCCBs ranges from 160 to 1600 amps. It has 7 frames: T1, T2, T3, T4, T5, T6 and T7. So it starts from 160 and ends with 1600 amps breaker. Here we are seeing the breaker sizes. This one is T1, T2, T3, which comes under one family, which means the accessories will be common for all the 3. Here T4 and T5 and T6. These 3 related to the next family. The 1, 2, 3 will have common depth, 70 mm common depth. 1 and 2 will have common height and width. We will see, inside. And 4, 5, 6, all the 3 will have common depth, 103.5 if I remember correctly. And T7 will be the individual breaker, nth breaker, which is of 1200, 250, 1600, which is almost equal to ACB. Because in ACB also we have 1600, in MCCB also we have 1600. There will be little bit limitation when compared to ACB. This one cost is little lesser. So now most of the parameters will be same. Only the additional luxury accessories won't be available in Tmax. So we can up to 1600 we can use MCCB. If in any case we need 2500 amps, we don't have MCCB. We have to compulsorily go with ACB only. But when it starts from 800, we have both MCCBs and ACB. It will be as per the client requirement. They want high quality, high end breaker, they will go with ACB. If they want moderate breaker, they will go with MCCB. Okay, and apart from these 7 frames, we have one single pole breaker in MCCB. Because 160 breaker is this one, T1 is the 160 breaker, which means it can be used from 1 amp to 160 amps. So normally, for 40 amps, if some customer needs MCCB instead of MCB, because MCBs have low breaking capacity. They are available only up to 10 kA, 10 or 16 kA. If customer is asking for 40 amps and 25 kA breaking capacity, so they need the MCCB. So which is needed for a single phase supply. They need single pole breaker. So that for that purpose, we have one single pole breaker in T1 only, T1 frame. So which is of 160 breaker. The breaker frame size is of 160, but we can change the rating plug between 1 to 160 amps. Like we have 16 amps, 32 amps, 40, 63, 80, 100, 125 and 160 rating plugs. We can interchange the rating plugs. The main difference between MCCB and MCBs. MCBs are low cost breaker. They don't have any adjustable parameters. They are all fixed. Same breaker only. But in MCCB, all the breaker have an facility to interchange the rated current. They have a rating plugs. For example, let's say if you are selecting how we selected the rating plug in ACB, in trip unit we have a rating plug. So for 1600 we will use it. For 1250, 1000 you can change the rating plug to a lesser value. Similarly, in all the MCCBs also, if in case of 160 amps, if you need 100 amps, we can interchange the rating plug from 160 to 100. Moreover, we can even some of the breakers have adjustable type also. That is, if it is an electromagnetic type, we'll go through this in detail inside the thing. I'm just going in preview only. If you're selecting a 100 amps breaker, we can change the rating plug of the breaker from 160 to 100. And if the overload protection we need is 90 amps, we don't have a rating plug for 90 amps. So what we can do, we can adjust the overload setting from 70 to 100% of the rating plug. In case of electromagnetic trip unit. In case of electronic trip unit, I think you should remember in ACB, we adjusted the overload parameters from 40% to 100%. So in electronic version, if the breaker rating is 1000 amps, the trip unit rating plug value is 1000 amps, we can adjust the value from 400 to 1000 amps. So each day we can set to a different value with respect to the load functioning. In MCCB we have 160 as well as 1600. So MCCB has both the electromagnetic trip unit as well as electronic trip unit, whereas ACB has had only electronic trip unit. In electromagnetic trip unit, we can adjust the overload value from 70 to 100% of the value, and we know already in electronic 40 to 100%. Similarly, the other difference between electromagnetic and electronic is in electronic we have LSIG variant, LI, LSI, LSIG. In electromagnetic we have only LI variant only, overload and instant short circuit, because electromagnetic means they perform with inverse characteristics. Like if the fault current is high, the tripping time will be very less. If the fault current is less, tripping time will be high. So both will be inverse in nature. In electronic, we have three characteristics. I hope we studied about this characteristics in relay section. When we are discussing about in definition part about the relays. There is another characteristic called extreme inverse. That is the current parameters, they segregate the current into two regions. One is lower fault region, another one is higher fault region. In lower fault region, it will be inverse. The setting will be different. In higher fault current region, again that portion also will be inverse, but that value will be different. If I have to recollect you, I will just go with one flow chart. Okay, text. Okay. Okay, it's not clear. Select this one only. Black. So this is y-axis and this one is x-axis. Here we can say like if the fault, let's say I will put the lesser value 1, 2, 3, 4, 5, 6 and 7. It can be amps or kiloamps or anything. I am putting ampere in x-axis, and in y-axis I am putting time. 1, 2, 3, 4, likewise 5, 6 and 7. Okay, 5, 6 and 7. Here I put time. It can be either in seconds or millisecond or microsecond. We have the liberal to adjust the values. So what I am drawing here is the inverse one. If what we can see is this is the fault current. Like for example, if you take a 100 amps breaker, or if you can say like okay, 100. The 100 is the normal value. So which means 101 is the fault value. 102, 103, 104, 105, 106, 107. So here 1, 2, 3, 4. 101, 2, 3, 4 will fall under low fault region. This one will fall under higher fault region. Because 101 is much lesser than 107 amps. So I am just giving this for an example. Time will be 1, 2, 3, 4, 5, 6, 7. So the inverse all electromagnetic component, they can behave inverse only. For example, we can the best example is we can tell about our energy meters. It is the old electromagnetic induction type energy meter, which will have this disc to operate. There will be two magnets, top and bottom. In between there will be a disc. So whatever voltage and current we are consuming, power we are consuming in our house, it will be given to the top, to the bottom. That is equal and opposite. So equal and opposite means that it will drive, it will create an EMF, electromotive force 90 degree in the top and opposite 90 degree in the bottom. So this opposite reaction will move the disc to rotate. I am speaking about the energy meter, the olden type energy meter which we use in our homes to measure the power. We should remember, like, if you are using more power, the disc will rotate faster. If we use less power, the disc will rotate slow. The calibration, how they will do calibration in the meter, like how we are measuring the power, like 1000 watts consumed per hour is called 1 unit. So what they will do, they will rotate the disc, and when the disc completes 1 rotation, it will show 1. If it rotates 2 rotation, it will show 2. If it rotates 10 rotation, it is still 10, it will show 10, and the unit will become 1. So when we use 1000 watts for 1 hour, this disc speed is calibrated so that after 10 rotation, it should reach number 1 unit. So for 1 unit, you will pay the EB bill, like anything 5 rupees or 10 rupees per unit. So all the electromechanical component or all the electromagnetic component, all physical component, they can perform only inverse. If you don't get my point, we can just directly relate this with this one, this bike speedometer, which we will have a wheel and this speedometer in the bike. So this wheel will be calibrated with this speedometer. Like they will measure the number of rotations the wheel takes to reach 1 kilometer. So how much rotation? So they will calibrate it. So once for example, if it takes 100 rotation to reach 1 kilometer, for every 100 rotation, the meter speedometer will show 1 kilometer. So it is what the calibration means. So what I am meaning here is, if the bike is going at 40 speed or 50 speed or 100 speed or even 200 speed, the calibration will be same throughout. Whenever it reaches 100 rotation, 1 unit will come. If the bike is going high speed, then 1 kilometer reach will be very fast. The time will be very quick. If we are going slow, the time will be very less. So it will be throughout inverse, irrespective of low speed or high speed. The calibration, the inverse characteristics will be same. Like we can see here, if the fault current is 1 amp, it will take 7 seconds. If the fault current is 2 amps, it will take obviously 6 seconds. If the fault current is 3 amps, it will take 5 seconds. And if it is 4 amps, it will take 4 seconds. 5 amps, it will take 3 seconds. 6 amps, it will take 2 seconds. 7 amps, it will take 1 second. So if the fault current is 100 plus 1, 11 amps, it will take 7 seconds to trip. If the fault current is 17 amps, it will take 1 second to trip. So which is quite good. It will be a cross straight line. It will be like this. This is called inverse characteristics. So now I am going to draw extreme inverse. These extreme inverse will come only under electronic trip unit, because electronic we have a programming module. So they program in 2 different characteristics. Any physical component cannot give 2 characteristics. They can be only 1 characteristics. We'll just draw this one. Extreme inverse here. Y-axis, x-axis. 1, 2, 3. Likewise, you can mention 4, 5, 6, and 7. So here also 1, 2, 3, 4, 5, 6, and 7. 1, 2, 4, 5, 6, and 7. Again it will be time, time, seconds, milliseconds, microsecond, whatever we can set as per our thing. So 4, 5, we already discussed this in relay topic. I'm just refreshing you. So this is amps. This whatever I did in the previous graph, this is the same graph. So here what my customer is asking, if my current is 101 amps, that is 100 is our last safe value. If the current is reaching 101 amps, it should trip at 7 seconds, like what we did earlier. If my current is 1 or 2 amps, it should trip at 6. 103, 5. 104, 4. They segregated this current into two sections, like lower fault current and higher fault current, because 100 is the limit. 101 and 107, there will be huge difference. So they don't want our breaker to operate in same behavior. So they want quicker trip for higher current. So they need two characters, like for 1 amps, similarly same thing what we did, 7 seconds, 2 amps, 6 seconds, 3 amps, 5 seconds, 4 amps, 4 seconds. So it will be a straight line what we did here. And customer is asking for 7 amps, they don't want 1 second, they want 0.5 second here. Or they might also ask for, we can also give 0.1 second also, 0.1, 0.2, whatever it is. So I'm just, for a clear graph drawing purpose, I'm doing this. Here, for 7 seconds, it will take 0.5 second. And here the interval is 1 second, here the interval is 0.5 interval. For 6 amps, it will take 1 second. For 5 amps, it will take 1.5. So this graph will be like this. So this is one inverse and this is one inverse. This inverse is of 1 second interval and this inverse is of half second interval. And between 4 to 5, no need to worry, we can just join this line. So between wherever it lies, the breaker will trip. Approximately between this 1.5 to 4 seconds. So this type is called extreme inverse. Electronic trip unit, which we used in ACBs. This one PR121, 123, they can also perform inverse type and they can perform extreme inverse also. And third one characteristic is that is called definite time. Irrespective of current, I don't have to worry about this inverse and all. Irrespective of current, my breaker will trip at a fixed time. We can, for example, we are sitting 3 seconds or 3 milliseconds or 3 microseconds. For 1 amp also 3, I'm just putting in the same graph. For 2 amps also 3, for 3 amp also 3, for 4 amps also 3. So it will be a straight line. So this is called a definite type. So here we discussed about 3 types: inverse type, extreme inverse type, definite type. Between voltage and current, so all electromagnetic devices like bike speedometer or electromagnet disc operated devices, all physical components, they can perform only this one, inverse. You can note it now. All other components, electronic components, they have all the 3 characteristics in the trip unit. They have to select in an electronic, it will have display. They have to select if this relay wants to operate in inverse, they will select inverse mode. In some other day, if they want extreme inverse, they will select this mode. In some case, they are getting confused. They don't want to go for inverse or extreme inverse. They want definite fixed time and put it to a lower current value. Whatever current it comes, the breaker will trip instantaneously. There they will go with the definite time. So using one relay, they can set all the 3 parameters one at a time. Because we cannot bring all the 3, at the same time. Because characters differs. So this is the benefit of electronic trip unit. But electromagnetic is, is also good only, since it is performing inverse. Inverse is much better than, if we are tripping in a fixed time means that is different. So our breaker is tripping with respect to the current, right? Current is high, it is tripping at a lesser time. The current is low, less, we are tripping at a higher point of time. So this inverse is more than enough, but in high current applications, if customers preferring for extreme inverse, they have to go for electronic trip unit. So I will summarize. This characteristics different. I'm just giving comparison between electromagnetic and electronic trip unit. Electromagnetic trip unit, we can adjust the overload values from 70% to 100%. In electronic trip unit, we can adjust the values from 40% to 100%. In electromagnetic variation, we have only overload and instant short circuit. LI variant only we can have. We can have overload protection and as well as short circuit protection. That is instant short circuit. We cannot adjust time in electromagnetic thing. That is, it will be inverse likewise. So this overload is from 0.7 to 1, right? 70 to 100%. In short circuit, we have different ranges is available. That is 10 times fixed is available in MCCB. 5 to 10 times adjustable is available. 2.5 to 5 times is available. 3 times fixed is available. 10 times fixed, 3 times fixed. 2.5 to 5 times adjustable. 5 to 10 times adjustable. This all the three cannot be available in one breaker. We have to select different breaker. For the same amperes, if customer is asking for 5 times of the rated current, we have to go with 5 to 10 times variable breaker. If they are asking 3 times or 4 times, we can go with 2.5 to 5 times variable. If they are asking fixed regular 10 into IN, they can go with fixed breaker also. Like MCB. MCBs they are tripping in fixed type. So 10 times rated current will be fixed. If they want a lesser tripping value, fixed value, we can go with 3 times fixed. Again, we will discuss about this trip unit in later section today only. So this is all about the electromagnetic trip unit. In electronic trip unit, as I said, it can be adjustable from 40 to 100% overload. Short circuit we can trip from 1 to 10 times or even 1 to 15 times if it is instantaneous. Then we can also set the values of earth fault protection, that is 0.1 to 1 times of rated current earth protection. In electromagnetic, we cannot give earth protection. For earth protection, we have to go with additional devices like ELCB or RCCBs or ELR, shunt trip, CBCT. Using that, we can go with this earth protection. So this is the main difference between electronic and electromagnetic trip unit. In ACB, we have only electromagnetic, so we don't have any issue. We just complete it easily. In MCCBs, we have both electromagnetic as well as electronic trip unit. Since here they have only 5 frames. Here they have 7 frames. MCCBs are moderately range breakers. So some customers will be preferring high quality, high cost MCCB. Some customers will be preferring low cost breaker. Someone will be preferring a middle level breaker. So they for example, if we take a 400 amps breaker, they will have one variant will be of electromagnetic type, one variant will be of a fixed variant, one variant will be of adjustable variant. So some 2-3 options are available. We can go with the customer's requirement and we can select the breaker. In ACB, we don't have no individual variants. In single breaker itself, we can choose whether we want PR121 or 122 or 123, whether we want LI or LSA or LSAG. ACBs are completely customizable. So, but MCCBs are ready-made only. So we have to go and select as per the customer requirements. But that don't be a big issue while selecting, because if you are going with 400 amps, there will be only 2 or 3 options. Which we want, electronic or electromagnetic, LI or LSA or LSA. We can go with the selection. So the selection won't be much complicated in MCCB. You don't have to worry about that. And the most important thing, as per the IEC standard, when we have to go with the electromagnetic trip unit and when we have to go with electronic trip unit. As per IEC standard, the recommended value is when our ampere range is lesser than or equal to 250 amps. When it ranges from 1 to 250 amps, we have to go with electromagnetic trip unit. But electronic is also available. If some customers will be preferring electronic in 160 amps, 200 amps also. So in that case, we can go with electronic because which is advanced to electromagnetic. But as per the standard, up to 250, electromagnetic version is enough. LI protection is enough. This inverse characteristics is more than enough. When it comes to 630 and above, 630 amps and above, we have to go with only electronic trip unit. That is the only reason ACBs does not had any electromagnetic. They had only electronic because it starts from 800 amps. So from 630 to 1600 or 6300, we can use only electronic trip unit. And in the middle range between 250 630, we can use both. Both are available. As per the customer requirement, we can go with electromagnetic or electronic trip unit. So this is the differences between electromagnetic and electronic trip unit. You just go through this session some 2 or 3 times because I discussed about some core technical points. So if you check this video 2 to 3 times, you will surely get an idea Even if you are a little bit confused, you don't have to worry, because inside we are going to see how to set the trip unit, what are the available trip unit, what are all the things I'm going to repeat everything whatever we have seen in this summary, so we don't have to worry about that.